Now, how do we how can we maximize first pass yield? The key point for us, and now I'm coming to the point where I want to convey to you new information. Okay, at least for some of you, I think that it's going to be new information. When we are gaining control over the detailed data that is accumulated during the manufacturing process, then we are able to gain end-to-end detailed control over the manufacturing process, identifying problems, resolving them, preventing them, and then this will impact maximizing first pass yield. Okay? Now, I know that you guys are testing your products. You get indication about pass or fail for every step in your production, in every type of testing that you are doing, and also after repair of repair activities. But the question that we are asking ourselves, do we really review the data to the extreme detail? Because if you rely on pass or fail only, this is not going to help a lot. And because let's take this example here of what we see above the sea level, so to say, on what is really important to see. Usually we cannot see below the sea level. Okay, we usually see repair, rework efforts, customer return faulty units, failures of products, machine downtime, faulty components, delay in delivery. These things are usually are easy to see. What is difficult for us to see if we don't have the detailed information, detailed information, it's difficult for us to see problems with the different tested parameters, wrong design problem, edge cases of components that are very close to their limits, and so on and so forth. This detailed information is very difficult to approach if we not have a full detailed access to our data. Okay, so why data is not available to us in a meaningful way when trying to improve the first pass yield? So we understand that the key point for us to be able to maximize first pass yield is controlling data, but data is not always available to us to the extreme detail. Okay, and why is that? The fact is that if you try to recall the different structures and protocol of data that are accumulated during your manufacturing process, including from your vendors, you will find endless types of data formats and structures and protocols that the data is saved and accumulated. Okay? It's not one type of data structure or one type of data format. Every machine, every sensor, every test equipment, the data is saved in totally different format. And this fact is a major problem. Why? Because the fact that it's saved in different data structures and format preventing us from getting the detailed information and run cross correlation between the different data sources. So in order for us to be able to overcome this, we need to find a technology, a capability that will enable us to unify the data to one digital twin database format, and then when we analyze the detailed data, we will be able to have a very effective outcome to see the problems in real time, to get automatic alerts, to prevent problems, and also to correct design issues and so on. Okay, so here we are starting to talk about artificial intelligence technology. Artificial intelligence technology enable us to make significant progress in two elements related to our process, related to the data. The first thing is integrating with the data and unifying it to a digital twin database, which speaks one database structure. And the second thing is using machine learning algorithms to analyze the data to gain the important insight out of the data to help us see the problems, prevent problems, predict what can go wrong, and by doing all of these activities, maximizing first pass yield. So eventually, when we are able to unify the data from every data structure, okay, what we call a holistic approach that can be achieved by using AI data integration, we are able to capture data from machines, from test equipment, from manual data, repair data, sensors, data that is kept in other systems. All of these different data sources in different format will be continuously collected in real time to a digital twin database, but here it will be structured in one unified data format, and then the analytics algorithms, including AI algorithms like machine learning, will be super effective because they will connect between the cause and the root cause, the problem and the reason for that problem, and also predict what can go wrong. Okay, so this is a major issue here. The vision that we want to create is exactly what you see in front of you right now. This is, I would say, the most important structure that we can dream about. And if we are able to gain this structure, our first pass yield will be amazing. Okay, we have many different data sources from machines, from test equipment, sensors, manual data, other systems, and so on. This structure can be accumulated in each of our factories, including from our contract manufacturers. Okay, and now imagine yourself that all of this data, it doesn't matter what is the format, will be continuously collected in real time, and we will reorganize in this digital twin database with a unified format, and then an algorithm, smart algorithms can analyze it and bring significant insight from this unified data.